In constructing the base plate for the sculpture, we initially consulted with traditional owners and the conservation organisation out at Twin Creeks. The conservationists and the elders selected 15 species of the region. It was then our task to construct a phylogenetic tree of these selected species. To do this task, I invited Gary Muir to work with me of WOW Wilderness Tours. Here you can see the species that were selected. We have the common name, the scientific name, and, where known, the indigenous name. It's important here to point out that the traditional owners did have names for all the species. Sometimes these names are no longer known. We decided to go with 8 animal species and 8 plant species for this sculpture. The first thing that Gary and I did was to research the Linnaean system of classification and how that applied to each species. The Linnaean system of classification is a series of clades at ever-increasing levels of scale. You can see here the pathway, if you will, through the tree of life from the kingdom to the species in each case. This includes the humans. When we had this data, we started to look at how to construct a phylogenetic tree in the round that would be overlaid onto the geological timescale. We were looking for shared ancestry of the selected species. This is the foundations for the creation of a phylogenetic tree. In this diagram, you can see that we've broken it up into 2 phylogenetic trees that are joined in the Precambrian, as being animals and the plants. Here we have the plants in orange and the animals are in red. We then created a model that clearly outlined the geological timescale. You can see the millions of years that elapsed through each period of geological time, and the phylogenetic tree of both the plants and the animals that was selected for the GeneStream sculpture at Twin Creeks. So instead of a geological timescale that reads from the lowest point to the highest point, we have the oldest area in this model in the center. Luca means the last universal common ancestor of this evolutionary tree, and the perimeter represents the present day. So the numbers you can see here are millions of years. To put this into context, let's run through the geological timescale. From the Ediacaran, we have then the Cambrian. Cambrian is this division period where we see the evolution of eyes. The first animals with eyes appear in the geological timescale. We then go to the Ordovician period. That's when Australia was just crossing the equator, moving into the southern hemisphere. It's spent the majority of its life in the northern hemisphere. After that, we have the Silurian period. This is where the first plants come onto land. We then have the Devonian period. This is where we find evidence of the first tetrapods, that's backboned animals on land, footprints. We have the Carboniferous period. This was a period of time in which there was huge forests. Oxygen levels were much higher than they are today. That meant that the arthropods could get a lot larger than today. Point being, we have spiders, say the size of your head. We have dragonflies the size of eagles. We then have the Permian period. In the Permian period, you see the appearance of the mammal-like reptiles, and at the end of the Permian period, this is approximately this 250 million years ago, that is the largest extinction event we've ever seen. It's also the time in which the ice retreated from this part of the world. There'd been major glaciations here in the early Permian. So with the retreat of that ice, that is the beginning of the story of plant diversity and evolution in the southwest. So for 250 million years, the sun has been shining on the oakbills of this land, which is staggering. This brings us into the beginning of the dinosaur time. The Triassic period is where we see Pangaea, all the continents are joined together. This is the first supercontinent to be forested. There'd been many supercontinents in the past that predate this phylogenetic tree. Then we have the Jurassic. This is the second period, the heyday of the dinosaurs, Triassic, Jurassic, and then Cretaceous. This is the last period of the dinosaurs, of course ending with the asteroid impact. We then move through the Paleogene, Neogene, and Quaternary. This is the time of the real radiation of the mammals. And so the phylogenetic tree is telling a story through deep time, through common ancestry. And when you enter this model, you're entering as a representative of the human species. The red line that runs from your entry point to the center of the sculpture in the diagram that you can see here is that element of the phylogenetic tree that is representing the humans. So at this one point, when you enter the phylogenetic tree, you are indeed a representative of all of humanity in this special evolutionary tree, which is about selected species at Twin Creeks.